Welcome everybody. So today what we're going to be doing is we're going to be talking about optimization. And the goal today is to be able to optimize for a variable using what we know so far with calculus. I'm going to warn you that this topic is difficult. I had the grade 12s write a reflection on which topics they found to be most challenging, and consistently optimization and what we're going to do next, related rates, were two of the hardest topics that they encountered in DP1 calculus. In DP2 calculus, there are obviously harder concepts, but in terms of DP1, optimization and related rates are some of the hardest problems you're going to encounter. Part of the reason is that each problem looks very different, and it's hard for me to give you like a step-by-step procedure for every single kind of problem because each problem looks very different. I will give you an overview and an overall structure and two approaches, but we can only do one example, maybe maximum two. I think you'll all be able to get it, but you do have to put in the work and you have to do lots of examples. Okay, so let's get into it. What is optimization? Well, optimization is just the ability to find the absolute maximum or the absolute minimum of a function. That's it. That's all it is. So the idea of optimization is just to optimize for a variable. Now, when we say the word optimize for a variable, usually what we want is the variable to either be a maximum or a minimum, and it all depends on the context. So like if you take a look at this graph down here, let's say, this is a really bad example. Let's say that we have profits for a company on the y-axis and number of employees, so the number of workers on the x-axis. And let's say we have a graph that looks something like this. I'm just kind of making up an example here, but it'll do. So in this case, what we want to optimize for is profits. Now, you might say, well, are we going to maximize or minimize profit? And the answer is obvious. The answer is obvious based off of the context. The context is the company wants to make as much money as possible. And so, of course, we're going to maximize. And so when we say optimize, it means maximize or minimize, but it all depends on the context. Okay, so what is the problem asking you to do? For us, if we're interested in maximizing the profit, we can see that the profit, this is the profits curve. And the profits curve, this is the dependent variable or the optimization variable. It depends on the number of employees. And you can think of the number of employees here as the independent variable. You can see that the profit might be maximized at a stationary point, or it might be maximized at an endpoint. And so here you do have to be careful. This kind of incorporates topics we talked about last class, as well as just basically in the past 2 weeks. It's kind of putting things together. But from last class, we talked about global maximums and minimums. For global maximums, they might be stationary points or it might be an endpoint. So you do have to carefully evaluate each and determine which is the true maximum. So I guess what I'm trying to say is if you're maximizing for a variable like profit, let's say, it might be a local maximum, it might be an endpoint. Similarly, if you're minimizing for a variable, it might be a local minimum, it might be an endpoint. And so you have to carefully kind of decide which it is and why. Okay, next I'm going to give you some steps, some overall procedures, I guess, that we'll take. And it's hard for me to give you steps because, again, each problem looks so different and it'll feel very different. But these are the overall sequence of steps that typically you can take to solve an optimization problem. The first is to just draw a diagram. Try and make the diagram as big as possible. Try and make the diagram as detailed as possible, depending on what the question is asking. A good diagram often goes a long way in solving optimization problems. The next step is to choose a variable to optimize. This, in our earlier example, was profit, but it can be whatever. It just depends on what the question's looking for. It'll be clear in the question what variable needs to be optimized. The third step, and this is where it starts to get a little bit challenging because you can see that there are quite a few steps, but step number 3, you have to express the optimization variable in terms of only one independent variable. And I'll show you how to do that in just a second with an example. Step number 4 and 5 are kind of connected. So step 4 is to find the stationary points and classify them. We talked about classifying stationary points. They can be local maxes, mins, stationary inflections. So you want to classify the stationary points because if you're maximizing for a variable, you want to know whether you're dealing with a local min or a local max. Because if you're maximizing for profits and you get a local min, well, the local min is useless, right? It tells you in the locality the function's y values are at a minimum, but that's not what you want. You want a maximum. So if you're maximizing profit, you only care about local maximums and maybe the endpoints. Step number 5, speaking of which, is the endpoints. You have to find them, especially for bounded intervals, like intervals that start at like one x value and end at another x value. For these ones, it's even more important to evaluate the endpoints, but you should always be thinking about endpoints. Sometimes the interval is not going to have it's not going to be bounded on both sides. And then you kind of have to do limiting analysis. Although I do feel that it might be beyond the scope of HL Math to do this. So I think in HL Math, if the interval is bounded, then definitely do the endpoints. If the interval is not bounded, then maybe just do a consideration in your head. For the end behavior analysis. Okay, and I'll show you what that looks like in a second. Number 6 is to identify the optimal solution. The optimal solution may be from step 4. It might be a stationary point. It might be an endpoint. Okay, and so that's important to keep in mind.